In order to solve for the second derivative of f, we must first solve for the first derivative of f. Now it's tempting to move this e to the negative x into the denominator and leave it as e to the x, and then use the quotient rule for differentiation, but it actually turns out to be much more intensive algebraically. So we are instead going to use the product rule, because we have a term multiplied by another term here that we can use. So first of all, doing the derivative of 5 times by the square root of x is 5 over 2 x to the negative 1 over 2, because the square root of x is the same as x to the power of 1 over 2. And then the coefficient 5 times by the exponent 1 over 2 is 5 over 2. Then we decrease the exponent by 1, so 1 over 2 minus 1 is negative 1 over 2. And that's multiplied by e to the negative x as it is. Now, we leave 5 times by the square root of x, and we derive e to the negative x. So the derivative of e to the negative x is negative e to the negative x. So that makes this positive a negative. And let's put this color as blue. Okay, and you'll see why. It'll make it easier now, because now we're going to do another 2 product rules for differentiation. So first, let's do it of this left-hand term. So we have f prime prime of x. Now we're doing the second derivative, or the derivative of the derivative. Okay, so let's derive this part of the first term, the part that I've circled. So 5 over 2 times by the exponent, negative 1 over 2, is going to be negative 5 over 4 x, and then we decrease this power by 1, so it's negative 3 over 2, and then we leave that term, so times by e to the negative x. Now we leave this term, so we have plus 5 over 2 x to the power of negative 1 over 2, and we derive this term. So the derivative of e to the negative x, as we've already done, is negative e to the negative x, which makes this sign a negative. All right, now we'll do the product rule for differentiation for the second term. So we have this negative that we're going to need to distribute into the brackets. So first we do the derivative of 5 times by the square root of x, and we did that over here. We know it to be 5 over 2x to the negative 1 over 2, and then we leave that term times by e to the negative x. Okay, now we leave this term, which is, so we have plus 5 times by the square root of x, and we derive e to the negative x. And as we've discussed twice before, e to the negative x derived is negative e to the negative x. So this positive sign becomes a negative. All right, now all that's left to do is to simplify. So we have the second derivative of f is equal to, we'll bring down that term, which is negative 5 over, and then that's to a negative exponent, so we can bring it into the denominator. So it's 4 times by x to the power of 3 over 2, and we can bring this e to the negative x into the denominator as well, as e to the x. All right, now this term is the same as this term, so we can simply subtract them from each other. And what I mean by the same as is that our x's are to the same degree, and our e is also raised to the negative x in both of them. So negative 5 over 2 minus 5 over 2 is just going to be minus 5. So we have minus 5 over the square root of x, and that's because x to the power of negative 1 over 2 goes into the denominator as x to the power of 1 over 2, and x to the power of 1 over 2 is the same as the square root of x. And then, once again, the e to the negative x goes into the denominator as e to the power of x. Now, we simply have this term, which is going to be, we distribute the negative, and it'll be plus 5 times by the square root of x over e to the power of x. And that's the second derivative solved for f. Thank you.